Our planet is not alone. That may sound like science fiction or the premise of a Halloween special, but it's a question grounded in science, astronomy, and 60 years of real-world investigation. For decades, scientists have whispered about something massive, something elusive, something that drifts through space alongside us, hidden in plain sight. And here's the kicker: it may be up to 9 times wider than Earth. Forget UFOs or alien probes. This isn't about Martians or interstellar messages. This is a ghost story told through starlight and math. It's about vast clouds of cosmic dust that might be silently trailing Earth in our dance around the sun, immune to detection by traditional means. These aren't fantasy, they might be real objects held in balance between gravity and momentum, perfectly positioned at places in space called Lagrange points. But before we dive into their discovery and the decades-long debate surrounding them, let's take a quick detour into what Lagrange points are and why they matter. Trust me, they're the secret coordinates to one of astronomy's most enduring mysteries. To understand how something so large can remain invisible, you need to understand the architecture of gravitational forces in space. When two large bodies like Earth and the Moon exert their pull, they create regions where a third, much smaller object can exist in a sort of gravitational sweet spot. These are known as Lagrange points, named after 18th century mathematician Joseph Louis Lagrange. In the Earth-Moon system, there are 5 such points. L1, L2, and L3 are unstable. Imagine trying to balance a pencil on its point, but L4 and L5 are stable. Objects in these points tend to stay put, forming equilateral triangles with Earth and the Moon. Because of their stability, these regions can attract and hold particles, dust, and even small asteroids for long periods. And that's where this mystery begins. In 1961, Polish astronomer Kazimierz Kordylewski claimed he had found 2 mysterious clouds at the L4 and L5 points of the Earth-Moon system. They were faint, ethereal, and unlike anything observed before. He captured photographs using long exposure times and photometric glass plates, revealing ghostly patches of light where theoretically no planets or moons should exist. But there was a problem. Other astronomers couldn't find them. Some tried and failed. Others dismissed them as optical illusions or atmospheric distortions. The tools at the time were limited, and detecting low-density structures against the black of space is a delicate game. Still, Kordylewski's claims wouldn't die. For decades, the scientific community was split. NASA even launched aircraft-based observation missions in the 1960s, flying high above light pollution to try and confirm the sightings. The orbiting Solar Observatory in 1966 noted some anomalous readings, but skepticism remained. In 1976, astronomer Siegfried Röser simulated dust movement at these points and found the sun's gravitational pull and solar wind too disruptive for dust to stay put. Radar observations around the same time found nothing. By the early 1980s, many dismissed the clouds as a misinterpretation or at best a transient phenomenon. Yet every few years, someone would claim to spot them again. Astronomer Maciej Winiarski photographed them from the Bieszczady Mountains in Poland in 1989 using advanced color photometry. His findings: the clouds were real, and they were redder than surrounding space dust, implying a different composition. So the mystery deepened. Were the clouds real? And if so, where were they coming from? Let's pause and consider something personal. Imagine being a young astronomer in the 1980s, trying to validate Kordylewski's claim. You're on a mountaintop in winter telescope, frosting over, eyes blurry from hours of staring into blackness. Every grain of dust in the lens, every flicker of light pollution could ruin your shot. One retired astronomer I spoke to in an email exchange described how he dedicated 5 years of observation time trying to find the clouds. He never did, and yet he never stopped believing in them. The math said they could be there, he told me, but sometimes math and nature have different opinions. Fast forward to 2018. A Hungarian team led by Judit Szlezbalog used modern imaging tools, including polarimetric photography, to observe the L5 region. Polarized light reacts uniquely when bouncing off dust particles, and when they compared the light patterns, they found something extraordinary. The data matched predictions. The clouds weren't just shadows or illusions, they were physical structures. Further simulations involving over 1.8 million digital dust particles showed how KDCs could form and sustain themselves under the right gravitational conditions. Finally, the ghost had a face. Let's get technical. These clouds are enormous, spanning nearly 100,000 kilometers in width, but made of particles so small they're nearly invisible to traditional telescopes. They're submicron in size, similar to bacteria. The clouds are not static. They're likely shifting with the moon's orbit, changing density and shape. Imagine a slow, swirling storm in space that forms, disperses, and reforms. That's what makes them so hard to track. They may literally vanish and reappear, depending on solar winds, moon gravity, and dust influx. Beyond the scientific fascination, KDCs matter for several practical reasons. First, they influence satellite paths. If spacecraft pass through them, instruments could be affected. Second, they offer insight into how stable equilibrium systems can trap matter, a concept useful in planetary formation and space navigation. Finally, they push our limits. These clouds show us that not everything in space is solid or obvious. Some truths hide in faint shadows. KDCs aren't the only odd companions of Earth. We've temporarily had mini-moons, small asteroids caught in Earth's gravity, like 2020 CD3. These are solid bodies different from dust clouds, but still fleeting cosmic visitors. Quasi-moons orbit the Sun, but appear to orbit Earth from certain angles. They're illusions born of perspective. KDCs, however, are unique, long-term, dust-based, impossibly billions of years old. Now that the L5 cloud is confirmed, the focus shifts to L4. Can we find similar confirmation there? Can better technology like radar, new space probes, or even missions like Artemis detect or map them more clearly? There's also speculation about how these clouds affect the broader Earth-Moon gravitational field. Could they change slightly during lunar eclipses? Do they have a seasonal rhythm? And here's a wild idea. What if other planets have similar dust ghosts? Could Mars or Jupiter have Lagrange point clouds we've yet to see? This story isn't just about science, it's about curiosity. It's a reminder that the cosmos still holds secrets, even right next to us. The Kordylewski dust clouds teach us that not all things worth studying are easy to find. Some require decades of patience, leaps in technology, and the stubborn determination of those who refuse to let go of a strange idea. So next time you look up at the moon, remember there might be something ghostly following behind it. Not an alien spacecraft, not a sci-fi monster, but something much more humbling, proof that we still have so much to learn. Let's keep looking.